Before we get started, let's take a moment to talk about safety. Although most professional concrete workers have never had any problems, wet concrete can cause chemical burns in some circumstances. You'll see workers in this tape who are highly skilled but are not observing all of the proper safety guidelines. The best way to avoid problems is to take some simple common sense precautions. The key is to keep wet concrete from coming into contact with your skin. Start with the right clothing. When you're working with fresh concrete, this means full-length pants and a long-sleeve shirt. And don't roll the sleeves up. Use waterproof gloves and rubber boots high enough to keep the concrete out. When you're placing concrete or sawing concrete, wear goggles to protect your eyes. If you're using a saw, wear a dust mask or respirator and earplugs. When using curing compounds, follow the manufacturer's instructions. Solvent-based curing compounds may require the use of a respirator and other personal protective items. Fewer safety precautions may be necessary for water-based curing compounds. And don't forget to wear your hard hat if there are any potential overhead hazards or lateral movement of equipment in your work area. Follow these simple rules, and you'll always be dressed for safety. The need for proper curing of concrete cannot be overemphasized. Curing has a strong influence on the properties of the hardened concrete, such as its durability, strength, abrasion resistance, and its resistance to freezing and thawing and de-icing chemicals. Concrete flatwork such as sidewalks, driveways, patios, garage floors, and basement floors are especially in need of curing because surface strength and durability, critical factors in their performance, will be greatly reduced if proper curing procedures are not followed. The objectives of curing are to prevent or replenish loss of moisture from concrete and to maintain a favorable temperature within the concrete. Curing should be started as soon as it is possible to do so without marring the surface, and it should continue for a period of at least 5 days when the air temperature is 70 degrees Fahrenheit or higher, or at least 7 days when the air temperature is below 70 degrees Fahrenheit. To understand how strength and durability are affected by curing, we must first understand that chemical changes are taking place within the fresh concrete as it hardens. As soon as water comes into contact with Portland cement, a chemical reaction begins. During this process, new chemical compounds are formed that bind all the ingredients in the concrete mix together. It is the formation of these new chemical compounds that ultimately affect the final strength and durability of the hardened concrete. The process continues for years as long as moisture and a favorable temperature are present. This chart shows how curing time affects strength gain. When continuously moist cured, concrete continues to gain strength with age. However, if curing is stopped and the concrete is allowed to dry, there is very little further strength gain. For comparison purposes, concrete continuously moist cured for 7 days will develop about 98% of its potential 28-day moist cured strength. Concrete moist cured for 3 days develops about 80% of its potential 28-day strength. And concrete not cured at all develops only about 55% of its potential 28-day strength. Most freshly mixed concrete contains considerably more water than is needed for the continuation of the chemical reaction. However, any appreciable loss of water by evaporation after the finishing operation will cause the chemical reaction at the exposed surface to slow down or stop. The rate at which the reaction occurs is also dependent upon the temperature of the concrete. Lower temperatures slow down the reaction, and higher temperatures speed up the reaction. The ideal temperature range for strength development is between 50 and 80 degrees Fahrenheit. Curing is usually done by spraying a liquid curing compound on the finished surface, fully covering a previously wetted surface with plastic sheeting or waterproof paper, or fully covering the surface with wet burlap. Liquid spray curing compounds are used to seal the surface and prevent evaporation of moisture from the concrete. Curing compounds can be applied immediately after final finishing while the concrete surface is still moist because they will not mar the surface. The spraying equipment used must be capable of laying down a smooth, even-textured coat. Care must be taken to see that the coverage is uniform and complete. Curing compound should be applied in 2 coats with total coverage of 150 to 200 square feet per gallon. The second coat is applied perpendicular to the first coat. White-colored curing compounds are commonly used because without them, it is sometimes difficult to tell which areas of the concrete surface have been sprayed. If clear compounds are used, they usually contain a quick-fading red color so that coverage can be verified as the spray goes on. Plastic sheet materials, such as polyethylene film, are an effective means of retarding evaporation, as long as they are held close against the concrete surface and the seams between adjacent sheets are tightly sealed. As soon as the concrete has hardened sufficiently to prevent surface damage, it should be thoroughly wetted and the polyethylene applied. Spread the polyethylene as flat as possible on the surface of the slab. Overlay adjacent edges about 6 inches and tightly sealed with sand, wood planks, or pressure-sensitive tape. Even the exposed concrete surface along the side of the slab should be covered and tightly sealed to prevent moisture loss. You should be aware that curing with plastic sheets can cause patchy discoloration, especially if the concrete contains calcium chloride and has been finished by steel troweling. This discoloration can be more pronounced when the plastic sheeting is allowed to become wrinkled, but can be minimized if the sheets are weighted immediately after being applied to keep them in close contact with the concrete surface during the entire curing period. Occasionally examine the concrete surface beneath the sheets, and if found to be dry, the surface should be re-wetted and the openings resealed. Waterproof paper is also an effective means of preventing evaporation. Its application is the same as described for plastic sheeting. Wet burlap is sometimes used to keep the surface wet because it can be applied almost immediately after concrete is finished without marring the surface. Care must be taken, however, to cover the entire surface, including the edges of the slabs. When using this procedure, keep the burlap continuously moist so that a film of water remains on the concrete surface throughout the curing period. Alternate cycles of wetting and drying during early curing contributes to crazing of the concrete surface. To eliminate the need for continuous watering, the wet burlap can be covered with plastic sheets. This will also eliminate problems of discoloration caused by plastic sheets. At the end of the curing period, allow the burlap to dry before removal. This will allow the concrete to dry more slowly and have less tendency to crack. The burlap used must be free of sizing or any other substance that is harmful to concrete or anything that will cause discoloration of the concrete surface. Before new burlap is used, it should be thoroughly rinsed in water to remove contaminants and make it more absorbent. Regardless of weather conditions, the requirements for curing concrete are always the same. Prevent or make up for loss of moisture from concrete and maintain a favorable temperature within the concrete. In hot weather, moisture can evaporate rapidly. In cold weather, concrete can freeze. Either condition can seriously affect the strength and durability of the concrete unless special precautions are taken. In hot weather, when air temperatures above 90 degrees Fahrenheit are expected, it may be necessary to cover the slab with plastic or wet burlap to prevent rapid moisture evaporation until the surface can be finished. Chilled water or ice can also be used during concrete mixing to lower concrete temperatures. Start curing as early as possible. Any delay in curing allows more mixed water to evaporate and increases the chances for cracking. Wet burlap curing for the entire curing period is best in hot weather because it prevents moisture loss from the slab and lowers the concrete temperature. The temperature of the curing water used, however, should be about the same temperature as the concrete to prevent problems that could result in cracking. If moist curing cannot be continued for the entire curing period, generally about 5 days, the concrete surfaces should then be protected from drying with curing paper, white plastic sheets, or white spray curing compounds while the surface is still damp. Don't use dark-colored coverings or dark-colored spray curing compounds since they absorb heat and can increase the already high surface temperature of the concrete. In cold weather, when air temperatures below 40 degrees Fahrenheit are expected, the fresh concrete must be prevented from freezing. Insulating blankets or layers of straw should be used to provide insulation against freezing. These materials, when placed over the top of a sprayed-on curing compound, plastic sheeting, or curing paper, will retain heat produced during the setting of the concrete. When insulating blankets are used, particular care should be given to the corners and edges of the slab, which lose heat more rapidly than other areas. When using straw, a layer at least 12 inches thick is required to insulate the concrete. Keep the straw dry, or its insulation value will not be satisfactory. Weighted tarpaulins, plastic sheets, or waterproof paper should be used as a protective cover over the straw to make the insulation more effective and prevent it from blowing away. Concrete is slow to gain strength in cold weather and must be protected until enough strength has developed to resist freezing, generally about 7 days. To prevent cracking when removing the insulating material, do it gradually over a period of hours so that the slab will cool slowly. Remember, with proper curing, concrete becomes stronger, more durable, more abrasion resistant, and more resistant to freezing and thawing and de-icing chemicals. This has been a presentation of the Portland Cement Association and the Aberdeen Group.